Now let's start with some momentum for IGCSE physics. So what is the formula for momentum? Momentum is equal to mass into velocity, which can be written as P is equal to mv. Now we have a formula, force is equal to mass into acceleration, which is Newton's second law. And we can write it in such a way that involves the idea of momentum. So F is equal to ma can be written as F is equal to mass into the change in velocity by the time taken. That is nothing but acceleration. So acceleration over here is equal to v minus u by t. And because of that, we can get this formula, which is force is equal to change in momentum by time taken. Now, what is the unit for momentum? Looking back over here, sorry, we have mass, which will mean that it is kg, and then velocity, which is meters per second. So that is one unit for momentum. The second unit is change in momentum by time taken. So we can write that as change in momentum is equal to force into time. Force is newtons, time is seconds. So this is another unit for momentum. Now, this is yet another formula. It's just another way of rewriting this, and this is the formula that we call the formula for impulse. Impulse is nothing but change in momentum, and change in momentum is equal to force into time. That is another formula we need to know. Next, conservation of momentum. This is a law which states that momentum in a system is always conserved, which basically means that P1 is equal to P2, and therefore M1 V1 is equal to M2 V2. And then we can, further just manipulate this formula to get something like this, but this is completely unnecessary, so we can just leave it out. Just one thing to note is that momentum before collision is equal to momentum after collision, because most of the questions revolve around the idea of collision. And if it is the idea of collision, then you can just use this formula over here. And the more general one would be the idea that momentum before incident is equal to momentum after incident. Incident, event, basically whatever the question has in it. Now there are different types of collisions. First one is the sticky collision, in which um, as you can see over here, they just stick together at this point and then move together with the combined mass. So if they both have a mass of 2, this one has a mass of 2 kg and this one has a mass of 2 kg, the combined mass is what we take into consideration when calculating the final momentum or the change in momentum. So the final velocity, the final momentum will be 4 into whatever the velocity is. So that is one thing to note, that it will be combined mass if it is a sticky collision, meaning that they stick together and move in the same direction. Then we have the non-sticky collisions, in which they bounce off in opposite directions. In this, the idea we have that we need to take into consideration is that if we take an object moving to the right to have a positive velocity, then an object moving with the same velocity to the left will have a negative velocity. So that is something to take into account. It doesn't have to be the same quantity, magnitude wise, but even if it's in the opposite direction, whatever the value is, it's going to be considered negatively. And the reason behind this is because as basically that velocity is a vector quantity, and so direction does matter. Now, I have some question over here, and this question over here relies heavily on the fact that when it comes to velocity, direction matters. So a gas molecule strikes the wall of a container, the molecule rebounds with the same speed. What happens to the kinetic energy and what happens to the momentum of the molecule? So let's start with kinetic energy. What is kinetic energy? Well, Ek is equal to mv squared divided by 2, or mv squared into 1 by 2, same thing. Now, if you look at this one, the mass of the gas molecule is unchanged because you're not told anything about it. And 2 is a constant. So the only thing that is actually changing is velocity squared, the velocity value. For over here, let's assume that this is positive v. So this is going to be what? Negative v. So does that matter? No, because there is a square over here. If the velocity is positive, it will be v squared. If it's negative, it will be negative v squared, which is again v squared. So technically, kinetic energy stays the same. So the answer is between C and D. Now, using the same logic that direction matters, the momentum will actually change. If we assume that this is the initial before hitting the ball and this is after hitting the ball, the before hitting the ball is mass and then v, and then minus, because after, this is going to be m into minus v, which will mean mv plus mv, which is 2mv, and therefore momentum did change. So the answer is going to be C. Now next, a ball is traveling with mass 2 at a speed of 12 meters per second, and it moves towards an object of mass 3 kg, which is at rest. So because this is at rest, it has a momentum of 0, and this one has a momentum of 12 into 2, which is 24 kg meters per second. Now the ball hits the object and it sticks to it. So because the total momentum is going to be the sum of these two, sum of this is going to be simply 24 kg meters per second. So this is the two possibilities. These are the two possibilities. Now we need to find out the final speed immediately after the collision. So when they collide, their masses will combine. So the combined mass will be 5 kg. So 5 kg into some velocity v is equal to the total momentum which was before the collision, which is going to be 24 kg meters per second. So therefore we get a value for B, which is 24 divided by 5 meters per second, which is going to be 4.8. So the answer is yet again C. Now next, a constant force acts on a body causing the momentum of the body to increase. And which expression relates the force to the momentum and the time taken? This is again simply change in momentum by time taken, which we discussed previously from Newton's second law. So now let's get to some theory questions. Okay, so 0.8 kilograms of water is emitted in the jet every 6 seconds at a velocity of 0.72 meters per second relative to the model. Calculate the change in momentum of the water that is ejected in 6 seconds. So in 6 seconds, the mass of water that is emitted is 0.8 kg. And the velocity at which it is emitted is 0.72 meters per second. So the momentum is going to be simply the product of that. So it's going to be 0.8 kg into 0.72 meters per second. So that's going to be the answer for the change in momentum, because the initial momentum is stationary. Even if it has a mass of 1000 kg, for example, a ton, for example, it will not have any momentum because its velocity is 0. The change in momentum is going to be caused due to the water, and that is why we only find the momentum caused by the water. And so the answer is going to be 0.8 into 0.72, which is 0.576. And we will simply round it up to give us 0.58 kg meters per second or Newton seconds. It's the exact same thing. Now the same question, but we need to find out the magnitude of the force acting because of the jet of water. How do you do that? We simply divide it by time, because the change in momentum we already know. Time we already know. Force is equal to change in momentum by time taken. So 0.8 into 0.72 divided by 6, and so we just take this divided by 6, which is going to be 0.096 watt newtons. Next question. This is the diagram over here. The small ship of mass 1.2 times 10 to the power 6 kg. The ship is moving slowly sideways at 0.04 meters per second as it comes into dock. And the first question is, calculate the kinetic energy of the ship before it hits the pillars. The formula for that is yet again just mv squared by 2. So mv squared by 2. Mass we know is 1.2 times 10 to the power 6. Velocity is 0.04. So we just square this and then we divide it by 2. So 1.2 times 10 to the power 6 into 0.04 squared. 0.040 is the same thing, but let's just write it as this: 0.04 squared and then into 0.5. 960 is the answer. So 960 watt joules is the unit for energy. Now the ship is in contact with the pillars for 0.3 seconds as it comes to a rest. Calculate the average force exerted on the side of the ship. Now the easier approach for this is just changing momentum by time taken, which is what I'm going to do. So the force is equal to the change in momentum is going to be, it comes to rest, right? So the initial momentum is going to be 1.2 times 10 to the power 6 into 0.04. Subtract from that, well, 0, because it comes to a rest, so velocity is 0. Mass is still whatever it is, velocity is 0, so momentum is going to be 0. Now the time taken is 0.03 seconds. So the answer for this is just going to be 1.2 times 10 to the power 6 times 0.04 and divided by 0.03, which is going to be this number over here, which is 1.6 times 10 to the power, let's count it, 1, 2, 3, 4, 5, 6. So 10 to the power 6 newtons. Now, assume that the kinetic energy in A is used to do work to move the pillars. Calculate the distance moved by the pillars. So now there's distance and there's energy involved. And so the only formula for this is that work done or the energy transferred is equal to force into distance. So the work done is basically the kinetic energy we calculated before, which is 960 joules. And this is equal to the force it experienced. The force over here is 1.6 times 10 to the power 6 newtons. So 1.6 times 10 to the power 6 newtons, and that is multiplied with d, which is the distance. So the distance moved is going to be, well, 960 divided by 1.6 times 10 to the power 6, which is going to be 6 times 10 to the power minus 4 meters, because meter is the standard unit for distance. And this can be written as, multiply that with 100, that will be the centimeters. So if you multiply that with 100, it will be 6 times 10 to the power minus 2. So 6 times 10 to the power minus 2 centimeters, which is going to be 0.06 centimeters. And that's it for momentum. If you have any doubts, feel free to write it in the comments and I'll get back to you as soon as possible. Yeah.